This video, let's talk about a chord diagonal called kite. Right, what exactly is a kite now? You can see the diagram here. This is a kite, that's a kite again. These guys are not kites basically. What makes a chord diagonal kite? There are two conditions. It says the kite has to have four sides only, right? So this guy has got four sides, this guy's got four sides. Even this guy's got four sides and four sides. Why are they not kites? So this side kites and this side not kites. Exactly, there are exactly two distinct consecutive pairs. Okay, this is very important. This distinct consecutive pairs of sides of equal length. Right? Consecutive means these two guys were next to each other. This is called consecutive, right? Now, in this case, I can say these two guys are consecutive. They're next to each other. Exactly, and they're equal also, right? This design says they're equal. But I can see in this diagram there are 1, 2, 3, 4, 5 sides. So that doesn't make it a kite, right? Now, in this case, why is this not a kite? Though these two guys are what? Are they equal lengths? They're not actually the opposite sides of equal lengths, alright? So I can see that opposite sides are equal length, but the consecutive sides are not parallel or equal in length, alright? So not important to be parallel, but they should be equal in length. So I can see that these two, the consecutive sides are not equal in length, but in fact the opposite sides are equal in length. So that doesn't make it a kite again. What about this guy? Though these two guys, it's a consecutive and they're equal in length, it doesn't make this a kite. Why is that? Look at this. Just because the other two guys also have to be what? Equal in length. So if these two are equal, the other two also have to be equal. So about the four sides, I can see now in this case, these two are consecutive and they're equal in length, and these two are consecutive and they're equal in length. These have exactly two distinct consecutive pairs. It means there should be two pairs. In this case, there is one pair, yes, but the other pair is not. That doesn't make it a kite. Alright? Very simple. So these are the two conditions where we can define or can say that the particular diagram is chord diagonal is kite. Now, based on this, we need to ask ourselves a couple of questions. Alright, the first guy is, has the kite any line of symmetry? Now, what exactly is the line of symmetry? Look at this. Symmetry says, for example, I have a face drawn again. Just try a face, two eyes, a nose, right? So that's a face. Let's go with that. Now, can I cut this face? Alright, can I cut this face in one fashion where both of them look like, look at this, right? So in this case, I can see if I fold the face on this line, I can see this eye will fall on this side, half the nose will fall, and half the nose, this will fall exactly. So it means this part is exactly equal to this part, correct? And if I fold this, the eye will fall on eye, this nose will fall on nose, and this girl will fall on this. That's called the line of symmetry, which cuts any diagram into two symmetrical faces, right? That's all it is. Now, do you think a kite has a symmetric line where it can actually divide the kite into two symmetric parts? Yes, it is. It's one line. So look at this. This line can divide the kite into two parts. I can say this line. Yes. Alright? Now, in this case, not necessarily, because we're not talking about non-kites, okay? Only about this. Now, the question is, will this also, the other lines, is this dividing the kite into two symmetric halves? No, it is not. So only one diagonal this side. Alright, this is not. This guy is not symmetric to this. Look at this. I have drawn the kite. Let me erase this. Talk about a little more so that you can understand better. So even that, two equal lengths and consecutive, and let's say this guy. Right, so that's a kite basically. It's a length kite. Right, now I can say that this line is dividing the kite symmetrically, but this diagonal is not. See, this is different from this. If I fold this, I don't see that these two are following each other exactly, right? But that's not. So I can say there is only one diagonal which can divide the kite symmetrically. Right? Good, we understand. Yes, we can say yes, there is one line, right? Second question to think here is, are the diagonals equal in length? They're not. Look at this. This diagonal is shorter compared to this side, so diagonal not equal in length. Third question, do diagonals bisect each other? Bisect each other. Take this example again. I can see that this diagonal is dividing this time, let's say this guy is AB and this guy is CD. So I can say AB is dividing CD, right, or bisecting CD. Definitely yes, because this is the midpoint of CD. Let's say M is the midpoint of CD, isn't it? So it means AB is dividing CD at M, or bisecting CD at M. But I cannot say that CD is also bisecting AB. No, it is not, because this length is small and this length is big. Definitely CD is dividing AB but not bisecting it. Alright? So we can say that the third one. Do diagonals bisect each other? Not each other. One of the diagonals would bisect the other diagonal. That's it. The symmetric diagonal basically would bisect the non-symmetric diagonal. Good enough. So is any diagonal an angle bisector? What exactly is an angle bisector? For example, let's say this diagonal, for instance, the same diagonal which actually divides it symmetrically. If this whole angle is 60 degrees, it is dividing into 30 and 30 here exactly. Exactly. That is a diagonal which can be an angular bisector also, or angle bisector also. In this case, this is the diagonal which divides symmetrically. So this angle, let's say if it is 40, this will also be 40. In fact, it is dividing this whole angle which is 80 into 2 halves. And for sure, here also if this guy is 20, this guy is also 20, it means this is the diagonal which is also an angle bisector, but definitely this angle is not equal to this angle, because they are not equal, right? This angle is not equal to this angle. Good enough. So it means I can say there is one diagonal which can also be called as angle bisector. These are the properties to be known in the quadrilateral called cavity, right?